Hi, and welcome to our 20th test and measurement video. Previously, we mentioned the spectrogram in the context of the amazing Tektronix MDO3104 oscilloscope's included spectrum analyzer. Now we'll discuss the spectrogram in a little more detail. As outlined in the previous video, we've used the built-in arbitrary function generator to provide a 25 MHz square wave signal. After pushing AFG, we're selecting square wave from the waveform menu, and we've gone to waveform settings to increase the frequency to 25 MHz. This is best done with the keypad rather than using multipurpose knob A, which is a slow process even with fine toggled off. As soon as you hit the first numeral in the keypad, the units menu comes up and you can press megahertz. All this is done with the AFG connected to an analog channel so that you can see what you've got. Then shift the AFG feed through the BNC cable over to the RF port, of course using the RF adapter. Press the RF button at the top of the column directly above the RF port. Notice the AFG button remains lit, indicating that it is still active. There is the spectrum analyzer display showing the 25 MHz signal. The y-axis still shows amplitude, but in power rather than volts. The spectrum analyzer vertical units are in dBm, with default reference level of 0 dBm being at 1 megawatt at the top of the display. We are now looking at a logarithmic scale. This is a little easier to see if you press span just below RF. The vertical frequency and span menu comes up, and you can press the bottom soft key, currently labeled R, to center. That shifts the fundamental to the center of the display, making everything more readable. In the spectrum analyzer mode, the x-axis is no longer representing time, but instead frequency. Notice that when the square wave is viewed, the greatest power is still in the fundamental, but there is also considerable power in the harmonics. This is in contrast to the sine wave, where all the power is in the fundamental. All this was originally conceived by Joseph Fourier. He developed the Fourier transform, not then in an electrical context, but having to do with heat transfer. He showed that through some complex mathematical operations, the time domain representation of a waveform could be decomposed into the frequencies that comprise it. The Fourier transform was subsequently restated as the much simpler fast Fourier transform, which can be accomplished in today's amazing oscilloscopes by simply pressing a button. The frequency domain can be shown in either an oscilloscope with the frequency analyzer capability included, or in a standalone bench-type frequency analyzer, or in the PC-based frequency analyzer such as the Tektronix RSA306. Now let's look at the spectrogram. To access it, press RF once more. The menu across the bottom includes spectrogram. Press the button and a new menu appears to the right of the display, so you can bring up the spectrogram by toggling on. Notice that the display starts at the bottom of the split screen and moves to the top. If you look closely at the graininess of the spectrogram display, which represents the noise floor, you will see that it is continually scrolling up from the bottom. That is because time is now represented along the y-axis instead of amplitude as in the two previous types of display, time and frequency domains. The x-axis still represents frequency, and we can see the vertical bars in the spectrogram that correspond to the fundamental and harmonics of the depicted square wave. Of course, we need to see amplitude. That is the object of the exercise. Now that the two perpendicular axes are taken, another method is needed, and so amplitude is shown by color. The hot colors represent the greater amplitudes, and the two cool colors represent the lesser amplitudes. Eventually, blue merges with the background, which represents the very low amplitude of the noise floor, intrinsic to the instrument. The great value of the spectrogram is that it allows the viewer to monitor slowly changing RF events. To navigate through the history of the spectrogram, first stop the acquisitions by pressing Run Stop at the top right. Press the slice control that is no longer grayed out in the side menu. Scroll through the history using multipurpose knob A. The history begins with the latest slice, which is at the bottom of the spectrogram. As you turn multipurpose knob A clockwise, you are moving back in time, as indicated by the horizontal line that moves up from the bottom, and after each change disappears after a couple seconds. The timestamp persists. Thanks for watching. New videos on today's amazing oscilloscopes are added periodically, so check back soon.